Looking at the plug and chug method. This plug and chug method works with functions where we have nice continuity. Are we good? Okay. And you know what nice continuity was? It's either the function is properly continuous or it just has a dot. In other words, you can fill it easily. And then we said when we evaluate these functions, what happens? We can put in the functional value. Right? Right. Then we said, how do we evaluate them? We can evaluate them algebraically. And we do this on the basis of substituting directly. Okay. So once you substitute in the value, you either get a real function. That means the limit exists if it pops out a number. Okay. Or it's undefined. Or you have an indeterminate form. If you have an indeterminate form, you factorize, you cancel out, you then substitute again. If you still have 0 over 0, you factorize again, cancel out, and substitute again until either it's real or it's undefined. Okay. If it's undefined, it means it tends towards infinity, or if it's real, it gives you an actual value. Okay. So let's look at a quick example. Let's take the function f of x, and I'm going to call this function x plus 3. Are you guys with me? So now we're considering the limit of f of x, right, as x approaches, say, the value 2. Of this function, which I can write out as f of x, I can further substitute the value of f of x in there and say, this is the limit as x approaches 2 for x plus 3. Now using our plug and chug methodology, to evaluate this limit, we're going to either get type 1, type 2, or type 3. We just need to take this 2, and where does it go? Into the x. So therefore the value, I don't write this word out limit again, once I actually assign a number to it, that gives me a value of 5. Are we good? Yes. Okay. So there the limit exists and the limit value is 5. Let's do another one quickly. The limit, what was that x squared one that I told you write down? X squared over x plus 5. And this is as x approaches what? Minus 5, right? Okay. So using our plug and chug methodology, which is the way we will do things in matric, is what will I do? I substitute, so I put in equal to, I substitute minus 5 in there, plus 25, all over minus 5, which is the x there, plus 5. And what does that give me? That's going to be 25 plus 25, which gives me 50, divided by 0. This is not an indeterminate form. Indeterminate forms are only 0 divided by 0. Okay. Now in this case, you know division by 0 is equal to undefined. So the limit is undefined, UD. Are we good? Okay. Now, graphically, what does this one look like? X plus 3 when we get close to 2. Let's see that. X plus 3 when we get close to 2. So when I get close to 2, here's 2, and I go, do you see that? Here's 2 on the x, and I end up at 5, right? Isn't that what we received here?
True.
Because that's the functional value, and if we had to evaluate it using partial limits, I run on this, and I end up there, and if I run on there, I end up there. Does it make sense, people?
Yes.
Let's look at the other curve very quickly. What was the other one? Where it tends towards infinity, where it's an asymptotic limit. X squared plus 25 over x plus 5. So let's x squared. So put that in. What was it? X squared, no?
Yes.
X squared plus 25 over x plus 5. Okay, now we look at this function. Do you see when you go towards minus 5, what's happening? The function never reaches the value of minus 5. And the y value continues to get bigger. Do you see this line? This is minus 5 here. Do you see that? That's minus 5. This, yeah, on x. That's the minus 5 coordinate. But as I go and I go and I go and I go, it will get infinitesimally close to infinity on the y value, but it will never touch minus 5. Do you guys now understand when we mean it may approach, but it may not necessarily touch? In the previous one, it approached and it touched. Right? No, because that's why it's an asymptotic limit, because minus 5 here is an asymptote. It never touches it. Do you see that? And when it never touches here, look here, do you see this? It is undefined. Okay, guys, let's do one last one quickly. This one, x squared plus 3x minus 10, that's my function, plus 3x minus 10 all over x minus 2. As now I want to evaluate its limit, so I say limit as x approaches what? 2 of this function. Limit plus 3x minus 10, right? Over x minus 2. Guys, let's finish this quickly. What do you do? First step, quickly. Substitute. So you put in the 2 plus 3 times 2 minus 10 all over 2 minus 2. And what do you get? You get 0 over 0. So that's an indeterminate form. When it's an indeterminate form, what should you be doing? You do it again. So now you're going to find the limit as x approaches 2 and factorize the top. What do you do here? Factors of 10 you subtract to give you 3 is what? X minus 2, x plus 5 all over x minus 2. Okay? Now when you cancel this out, you're now looking for the limit equal to x approaches 2 of x plus 5. Now what do? You substitute. And when you substitute into that, you're going to get 2 plus 5, which gives you a limit of 7. And now just very quickly, graphically, what does that look like? X squared plus 3x. X squared plus 3x minus 10. What was the denominator?
2.
X minus 2. Right?
Equals.
Where's this function? Is it there? Home zoom. Do you see that? And as you can see, when we approach 2, you end up with 7. Are we good? Okay, you have about 50 limits to do for homework. Very, very simple, very, very easy, okay?